Hi students, in this class we will learn about electric potential and potential difference. To understand the concept of electric potential and potential difference, you look at this diagram. You can see two water tanks, tank A and tank B. Tank A is filled with water up to this level and tank B is filled with water up to this level. The height B, let it be h. The height h is more for water tank A and hence the potential energy of tank A will be more than this tank B. If you open this tap, water starts flowing from A to B. If water should flow, there must be a difference in potential. Similarly, heat also flows from higher temperature to a lower temperature. The heat always flows from a hot object to a cold object. In our previous class, we learned electric current I as I is equal to Q by T. I is the flow of electric current is the flow of electric charges. For the flow of this charges, you need potential difference. Electric current is the flow of electric charge. Electric charge also flows from a higher potential to a lower potential. Let this point be A and this be B. A is at a higher potential and B is at a lower potential. Say a charge Q moves from A to B. This difference in potential between these 2 points is provided by a battery. This positive polarity of the battery is at a higher potential. Therefore, this point A will be at higher potential. This negative polarity of the battery is at a lower potential. Therefore, the point B will be at a lower potential. The charges can flow from A to B. If the charge Q should move from this point to this point, this charge Q must be pushed, and this force produces a displacement. We all know that force into displacement will give you the work done. Therefore, the potential difference between 2 points can be defined as the work done in bringing a unit charge from that point to the other. The potential difference between 2 points in an electric circuit is equal to the work done in moving a unit charge from one point to the other. This potential difference is indicated by the letter V. V is equal to W by Q. It is the work done in moving a unit charge. If Q is equal to 1, unit charge means Q is equal to 1. If Q is equal to 1, V is equal to W. Therefore, you can say potential difference between 2 points. Difference is always between 2 points. You cannot say difference otherwise. Potential difference between 2 points in an electric circuit is equal to the work done in moving a unit charge from one point to the other. V is equal to W by Q. Work done is a scalar quantity. Therefore, this potential difference is also a scalar quantity. We learned the potential difference between 2 points. Now, let us learn about the potential at a point. Potential at a point is the work done in bringing a unit charge from infinity to that point. In the previous slide, we learned about the potential difference between these 2 points. In that case, the work done in bringing a charge from that point to the other point. But when you are talking about electric potential at a point, you have only one point. In that case, electric potential at that point is the work done in bringing a charge from infinity to that point. Electric potential is the work done per unit charge in bringing the charge from infinity to that point against the electrostatic force. It is from infinity to that point. It is also a scalar quantity. The electric potential at this point, say A, is the work done per unit charge in bringing the charge from infinity up to that point. For this point B, you should bring the charge from infinity up to that point. The work done per unit charge in bringing the charge from infinity to that point is called as potential at that point. Potential difference V is equal to W by Q. The unit of W or work done is joule and unit of Q, the charge, is coulomb. Joule per coulomb is called as volt. Volt is the SI unit of potential difference. 1 volt is equal to 1 joule divided by 1 coulomb. Potential difference between 2 points is said to be 1 volt when 1 joule of work is done to move a charge of 1 coulomb from one point to the other. How do you measure potential difference? This potential difference can be measured using an instrument called voltmeter. Let this be a resistor and you have to find out the potential difference between the endpoints. So between these 2 points, say AB. What you should do to know the potential difference between these 2 points, connect a voltmeter across those points. This voltmeter will give you the potential difference between the points A, B. This instrument is always connected in parallel. This is a simple circuit diagram where battery is shown and this is a resistor and you have to find out the voltage or the potential difference across the resistor. You connect the voltmeter across those points. This voltmeter will give you the potential difference or the voltage. Ammeter is the instrument used to measure the current in a circuit and this ammeter will be always connected in series whereas voltmeter is always connected in parallel. Voltmeter is an instrument used to measure the potential difference and it is always connected in parallel across the points between which the potential difference is to be measured. In this session, we learned about potential at a point, potential difference and unit of potential difference and how you measure this potential difference. Potential at a point is defined as the work done in bringing a unit charge from infinity to that point. Whereas the potential difference between 2 points is defined as the work done in bringing a unit charge from that point to the other point. And potential difference is measured using volt. Volt is the SI unit of potential difference. 1 volt is equal to 1 joule divided by 1 coulomb. And how do you measure this potential difference? You can use the instrument called voltmeter to measure the potential difference. Remember, the voltmeter is always connected parallel in a circuit. Electric current is the flow of electric charges, and for the flow of electric charges there must be a potential difference. Charge will always flow from a higher potential to a lower potential. I hope you understood the session. See you in the next class.